Okay, so welcome to the very first lab of general ecology, and the very first lab is on GPS and global positioning systems. And as a preparation, I want you to read the entire chapter, chapter 3 of the lab manual. Like I mentioned earlier, lab manual is required. One of the required texts. So by now you should have the lab manual with you. So number one, read chapter 3 of the lab manual entirely before you start listening to this PowerPoint presentation, or before you start listening to this video presentation. Um, Now in the video you are looking at our Blackboard lab page. So I'm navigating to course contents and then GPS exercise, right? So here you get access to everything you need that is not directly available through the lab manual. For example, here you have some details about global positioning systems and some information about the unknown GPS locations that you require to complete the lab activities. The mystery location, again, this is also provided in the lab manual. And then the lab worksheet that you need to submit online, a link to Google Earth Pro to be downloaded and installed on your desktop, and ultimately the link across which you have to submit your completed lab worksheet. Okay, now like I said, first things first, read the lab manual completely. Alright, now you are looking at Google Earth Pro. It's a desktop version of Google Earth. So I earlier showed you a link to download this. So after reading the lab manual, the next thing you do is download that free version of Google Earth Pro and install that on your laptop or on your computer. Now there is a browser version of Google Earth, and there is regular Google Maps. In order to fully learn the GPS system, I'm going to use the Google Earth Pro, which is freely available and should not be difficult to work with. So now when you launch your Google Earth, in order to first to see what a global coordinate system is, or what a global position system, in order to know what a global positioning system is, we have to turn on the grid system. So by default, right, Google Earth does not have a grid system, comes like this. So what you want to do is you go to View, scroll down to this grid, and the grid system comes up. Now by now you should recognize what this grid system really is. It's latitudes and longitudes. That's one of the coordinate systems that we use, and in fact one of the most commonly used coordinate systems in global positioning systems. So some of those lines extends from east to west, right, and they are parallel to each other, right, and they are called latitudes. These are called latitudes. That goes from east to west, east to west, east to west, right? And those are the latitudes. And equator is a latitude, Tropic of Cancer is a latitude, Tropic of Capricorn is another latitude, right? And they spread from north to south. Those who are north of equator are northern latitudes. Those are south are called southern latitude. Hence this N's and S's. What are the other types? Look at those lines that are perpendicular to the latitudes. Those are longitudes. They extend from north to south, and they also parallel each other, and those are called longitudes. Now longitudes, on the western hemisphere you have western longitudes. On the eastern hemisphere, on the eastern hemisphere, right, you have eastern longitudes. Look what happens to that when I actually scroll around the globe. Okay, now I mentioned latitudes and longitudes are one of the coordinate systems on the earth, right? And there are other coordinate systems. One of them is called UTM, Universal Transverse Mercator. And in fact, there are countless number of coordinate systems. And some of those coordinate systems, like latitude and longitude, are global, right? They are designed, drawn to represent the entire planet Earth, and some of the coordinate systems are actually scaled to very specific location of the planet, right? Now UTM, Universal Transverse Mercator, which is actually a global scale positioning system, has been it has actually, in order to increase the accuracy of expressing spatial coordinates, UTM has divided the planet Earth into many squares across the entire surface, and each square is then subdivided into things like latitudes and longitudes. Now, I'm not going to go over the UTM system, but I'm going to talk about this latitudes and longitude based system, because which is very commonly used, which is very well known, and it's easy to understand. Now, what is the connection between a GPS, global positioning system, and a coordinate system? Well, coordinate system, like you're looking at, is a grid system that looks like axes of a graph, x-axis and y-axis. In this case, if you look at the latitudes and longitudes, latitudes represents one axis and the longitudes represents the other axis. Like it's like x and y axes of a graph. So a coordinate system helps you to pinpoint or describe a particular location, right? If I drop a pin like that, right, on somewhere, right? I know it's over here right now. Let's say, if we drop a pin on, don't know where I'm zooming in. I'm in somewhere in the center of the United States, right? It actually, if you click on that one, let me redo that. If I drop a pin somewhere, right, on the center of the United States, let's do it there, right? And you can see when I drop a pin, it actually opens up this dialog box. So I'm going to just zoom in just to see where I am. It's somewhere alongside a river, and you can see it's this. I can drag it around. Let's say I drop it randomly over here, right? And it actually tells you what latitude, what longitude is. And if I move this around, you can see lat and long changes in that dialog box, right? And so these are the different coordinates. Those specifically identify the location in terms of latitudes and longitude. So what is a coordinate system? Coordinate system is a grid system, a grid network that helps you to specifically pinpoint a particular location on a map on the planet Earth. Now, theoretically, you can actually create a grid system or a coordinate system for the moon, for another planet. It's the same principle, right? And in fact, in space explorations, people do have created, right, coordinate systems for other planets, right? And now you might ask me the question, okay, wait around, this is a latitude, that's also a latitude, this is also a latitude, the northern latitude, right? I mean, how do you describe anything in between? Well, in order to do that, latitudes are subdivided into two more other categories, right? Minutes, degrees, and seconds, right? 60 seconds comprises of 1 minute, 60 minutes comprises 1 minute. So because of that, when you call coordinates, right, when you record coordinates, that's why you see these three numbers over here, like the same numbers you see over in the dialog box, right? This one is actually, on which side, right? So this is we are looking at longitudes, so western longitudes. The first reading 97 degrees, that's actually the degrees component, right? And then 43 minutes, that's tiny little stroke over here, right, is minutes, right? And 45.12 seconds, that's how you read it, right? That's why you see these three components, right? Degrees, minutes, seconds. The same thing regarding latitude, right? If you look at over here in this one, N, northern, so you are north of the equator, 39 degrees, 13 minutes, 45.12 seconds. So a minute is much more larger spatial scale. Sorry, a degree is the largest spatial scale. Minute is slightly smaller spatial scale, smaller than a degree, right? But larger than a second, and seconds are the smallest in spatial scale when you are pinpoint to a particular location. And remember, like in this dialog box, you can even name this under something else, right? I'm calling it random one, and then you can hit one and it'll actually stay there. And if you don't like it, right, you can get back to the properties and change it, right? Or add a description over here, right? Not over there, that's actually the name. Over here, you can even add a particular description, okay? I'm not going to save it. And if you completely don't like it, you go over here on the left side, right? Right click and delete, right? So you can get rid of that. Okay. And once again, like when you have a particular point like that, let's actually have it over here and let's mark it okay. In order to move that, right, you'll actually have to have the properties box on, right, by left clicking on that, or right clicking on that. Let me redo that. And here, right, okay, right, I want to move it. Click my right mouse button and go to properties. Right now you can actually move it around. All right, I am going to delete both of them because that was just for the demonstration purpose. Let's talk about the difference between global positioning system and a coordinate system. Well, in fact, they are not that different, right? They are quite identical, right? I mean, you can use them interchangeably. A GPS, or a global positioning system, is actually based on the coordinate system I just mentioned to you. Now, the textbook says that latitudes and longitude system is a GPS system, well, which is true, but remember that lat and long, latitudes and longitude, is not the only coordinate system that can be used by a GPS system. In fact, like I mentioned, there's about if I counted over 40-50 different types of coordinate systems, and certain systems are more accurate in terms of pinpointing to a particular location. Certain systems are more accurate in terms of preserving the shape of the map, and certain coordinate systems, certain GPS systems are better at accurately pinpointing towards the elevational changes, right? Like that, based on certain geographic features we are interested in correctly representing in a map. Geographers have defined different types of coordinate systems, different types of GPS systems. So GPS system, coordinate system, they are used interchangeably. They don't mean different things. As far as for your concern, it's completely okay to use those interchangeably. Now, what is a GPS unit? The thing that you measure like out there in the field. Now that is a GPS unit which actually can read coordinate systems, and can function to understand the global positioning system of a particular location, right? How it does that is actually by communicating with satellites. When you turn it on, with some time it will communicate with satellites, and usually GPS units or GPS receivers, they will communicate with global positioning satellites, usually somewhere between 4 to 5 satellites. Sometimes 3 is good enough in certain more advanced ones, and they will actually using multiple satellites, they will determine the location. The more satellites you connect to, the better, the more accurate your location is. And sometimes certain GPS devices can even record the elevation, right? And again, more older versions actually do it in a different way. Recent versions communicate with the satellites to determine the location. And if you look at Google Earth on the right hand corner, right, it actually gives you the elevation, right? Now, that's a very basic recap of coordinate systems and GPS systems, right, or GPS units. Now, In this lab, we are not handing over any GPS units for you. So what you are going to do is use your cell phone, right, as a GPS unit, right? Any smartphone, Android or Apple, have the capacity to record GPS, right, or to function like a GPS unit. And separately, I will upload another short video on how to use Google Maps on your smartphone to read GPS locations of a particular site. Now, what we are going to do is take a look at your lab worksheet and try to understand what you are supposed to do, right? So before you turn into the worksheet, right, if on page 24 of your lab manual, it describes two different activities, exercises that you are required to perform on your own.